Assalamu alaikum, I'm Mahmoud Sameh, wait and see, and inshallah in this video, as you can see, we will be answering questions and explaining moles, molar mass, and empirical formula. So let us start by the first slide. What is a mole? So moles is the measuring unit of substance, and it's defined as 6.02 times 10 power 23. So mainly moles is like a dozen. A dozen is 12 of something. Like if I say that I have a dozen of pencils, that means that I have 12 pencils. And moles are the same. So if I say that I have 1 mole of pencils, that means that I have 6.02 times 10 power 23 pencils. And that is a massive number. And actually, I'm going to be discussing this number on later because this number is very cool and there is a lot of mysterious things behind it. So this number is called Avogadro's number, and yes, as you have guessed, Avogadro is the scientist who discovered this number. So, for example, I can say that I have 1 mole of C12H22O11. I don't know what that is, but I believe it's a compound. And I can say that I have 1 mole of NaCl. I know what that is. And I can say that I have 1 mole of carbon. So I just wanna clarify how this number is huge. I heard the fact that saying that if we had Avogadro's number of jelly beans, that means that we have 6.02 times 10 power 23 jelly beans, it will cover the whole Earth. It will cover the entire Earth. Can you imagine this? So how can you imagine 1 mole of NaCl and 1 mole of carbon and 1 mole of this weird compound? Of course, it's huge, but actually, it's not. It's not as you have imagined. This is 1 mole of carbon. It's fit in a tiny plate on a tiny balance. So that shows how tiny atoms is. So now, if you noticed in this picture that we have that this carbons in on the plate on the balance measured 12 grams. Doesn't this number seems familiar for you? Yes, it is. 12 is the AMU of carbon. So carbon have 12 AMU. So, and that is the cool thing about this number. If we multiplied 12 AMU by Avogadro's number, that will give us 12 grams. That will give us the mass of this atom of the. For example, if we got nitrogen, nitrogen has 14 AMU. Then we multiplied 14 by Avogadro's number. It will give us the mass of the nitrogen, and that is what happened here. We multiplied 12 by Avogadro's number, so it will give us the mass of carbon, and the mass of the carbon is the same as the AMU. AMU, by the way, is the mass of this carbon, but in a tiny unit. So Avogadro's number have helped scientists in measuring the mass of atoms, but in grams instead of AMUs because they're really tiny. So this number, this mass is called the molar mass. So the mass of the sample is its molar mass. So let's hop into to the first question. It says calculate AMU in caffeine, C8H10 and 4O2. So that's a very basic and easy question. We should just see the AMUs in this compound. So what we will do is that we will look at carbon. We will need a periodic table. So hopefully you have a periodic table somewhere near you. So that we will look at the carbon in the periodic table and we will see the number of its AMU. So I have a periodic table here. It has 12 AMU. Then we will multiply it by the number of carbons that are found in the compound. So we'll multiply 12 by 8, which will be 96 AMU. Then we will do the same thing with hydrogen. We will multiply 10 by 1, which is the AMU of hydrogen. So that will be 10. Then then we will do the same thing with the nitrogen. We'll multiply 14, which is the AMU of nitrogen, by 4. So that will be 56. And I will leave you 5 seconds to guess what will be the oxygen AMU. I think you have guessed. So yes, it is 32 AMU. Then we will add all of the AMUs together that we have collected. 96 plus Yes, 96 plus 10 plus 56 plus 32, which will be 194 AMU. So that is the mass of this compound in AMUs. If we want to convert it into grams, it's the same number. We don't need to convert it. If we multiplied it by Avogadro's number, we will get 194 grams. I hope that that my words are clear and you can understand till now, because that's super important. The moles is very important in chemistry. So question two is how many moles of CH4 are present in 6.07 grams of CH4? That's a little bit complicated, but it's very easy. So we will do the same step as we did in the last question. We will see the compound that we have. We have carbon. We will see the AMU of carbon in the periodic table, and we will multiply it by the number that we have. So that will be 12 times, sorry, that is the carbon in the periodic table, and that is the hydrogen in the periodic table. So as we can see, the carbon has 12 AMU. We multiply 12 by 1, which is 12. And then hydrogen, we will multiply 4 by one because we have four hydrogen atom, and the the AMU of hydrogen is 1, so we make 1 times 4, which 1 times 4, yes, which is equal to 4. Then we will add them together, which will be 12 plus 4 equal 16 AMU, or 16 grams, because we will consider that we have multiplied it by Avogadro's number, and it will give us the same the same number, but in grams. Now here comes the fun part. We will make cross multiplication to get it in moles, to get 16 grams, but in moles. I mean, yeah, to answer the question. So we will write the number that is given, this number. So let's start writing here. 6.07. I know that my handwriting is perfect, so please excuse me. 6.07 times 1 mole over 16 grams, because we 1 mole is equal to 16 grams for this, for the CH4. I mean, that's a basic cross multiplication. I do it that way. If you have another way, you can do it. You're free. So by that, we will have 6.07 times 1 mole over 16 grams. It looks like a 9, but it's grams. Don't worry. So that will be 6.07 over 16. You can use your calculator. It will be 0.379 or 0.379 moles. So that's an S, by the way. I read the S this way. I'm sorry. Uh, so that's the no the so that's the moles that are found in CH4 that are present in 6.07 grams of CH4. Calculate the number of moles in a 1.52 kilograms. يعني keep an eye on this. 1.52 kilograms of glucose C6H12O6. So first of all, we will do the same step as we do every time. We will look at the compound. Yes, we have it here. Um, yes, we have it here. C6H12O6. We will look at the carbon. Hopefully you have memorized it. Carbon have 12 AMU, so we'll multiply 12 by 6. That will be 72. And then hopefully also you have memorized it that hydrogen has 1 AMU, so that will be 12 times 1, which is 12. And then oxygen has 16 AMU, which will be 16 times 6, and that will be 96. Finally, you will add them all, which will be 180. Then you will convert from 1.52. We need to convert 1.52 kilograms to grams, because Avogadro's number shows the mass of the element in grams, not in kilograms. So we should convert 1.52 kilograms into grams. So that will be 1.52 times 1,000. So that's how you convert it. It will be 1,520. Then the fun part, plus multiplication. We will make 1,520 and 20, which is the number that is given. Sorry, 2020 grams. Yes, it's grams because we have converted here to grams. And that will be 1 mole over one 180 grams. I put the grams down and the number that's given up because I want to delete the 2 units. So moles is the unit that's remaining. So that will be 1520 over 180, and that will be 8.44. That is that is the number. And that's it for this video. Thank you so much for watching. I hope you have understood anything from this video, and see you in the next video. Thank you for watching.